A Fred and Barney style question is any question where two objects have to be or end up being in the same place at the same time. So it's like, I mean, the Fred and Barney is a stupid one because they're running into each other, right?
Yeah.
But the Jack catching the bus, right? He wants to catch it. He needs to be at the same place at the same time. Now, it could be like another car that goes out to pass another car, and they're like side by side, or I mean, it could be any situation that in my imagination you can come up with where two objects are in the same place at the same time, right? You're chasing a dog and you catch the dog, or the dog's chasing a cat, or the dog's chasing a ball, or why not have the dogs? But any time when two things are the same place at the same time. Alright? So you set that up in the Fred and Barney style, and you set the positions equal to each other, and you solve for the time. That's kind of the main idea, right? So let's look at this one here, which is not a Fred and Barney style question, by the way. So this one is from the problem pack. It's number 15, is it right?
Yep.
15. It's rated a 3 for difficulty. It says, a person driving a car at 50 kilometers an hour approaches an intersection just as the traffic light turns yellow. Well, I think there was a picture, was there not?
Yep.
Okay, so let's get the picture too. Okay, so the car is approaching the intersection. She knows that the yellow light lasts only 2 seconds before turning to red, and she is 30 meters away from the near side of the intersection. No idea how she determines that. Although I think the 2 seconds is probably fairly safe, would you not think?
I would, because don't you got like 3
Sometimes
seconds
it's
before-
more. I don't want to do
So
it.
it is? This is the data we're getting, right? Apparently I got a friend right now, he's traveling in Iceland, and apparently when it's a red light, it turns yellow before it goes green. Tells you to like, get ready to go. It's kind of cool, eh?
Watch the lights.
No. Not everyone's as smart as you thought, Allison.
What if you can't see the other way?
They're right there. You're
What if you're
actually
on
not
an
seeing them.
angle though?
Have you ever come?
Well, you'd be at a right angle, right? But yeah. Anyways.
It depends.
So the question is, should she try to stop, or should she make a run for it? Okay. The intersection is 12 meters wide, ladies. I know, but I'm sorry that I got distracted. The intersection is 12 meters wide, and her car's maximum deceleration is -6. Also, her car takes 7 seconds to accelerate from 50 to 70. Ignore the length of her car and her reaction time. So we're going to try and get settled. So in other words, you got to figure out, can she stop, or can she go that far in the correct amount of time? That's really what the question is. Both could be possible. Both could be possible. Okay. So which one should we do first? The can she stop one?
Yeah.
Okay. So we're trying to find out if she can stop. So the distance to stop is 30. Right, EJ? Distance to 30 is stop. She is traveling at an initial velocity of 50, and her final velocity has to be 0. So she has to go from 50 to 0 in 30 meters with an acceleration of -6. So which formula has, like I could go VF squared equals VI squared plus 2AD. And the final velocity is 0. And the initial velocity is, I got to take that 50 and do what?
Convert it into meters.
Convert to meters per second. Can I do this? I don't know if you guys are going to let me. Karen, you should watch. Is that Mom?
Nope. Can't do that.
Can we do that?
Yeah. Yes, you can, but it's confusing and I don't want.
So you're okay with it, but you're not okay with it.
Yeah.
Karen, I just forgot, that's all.
So what time is that?
All I'm doing is dividing by 3.6 and then squaring it. Can I do that?
No, it's
Well,
solving for acceleration here, right?
Well, okay. Actually, I wanted to point this out. Just hold that thought, okay? Just hold on. Just hold on, Christine. Plus 2. What's the acceleration? -6. And the distance traveled is? 30. But here's the problem, which Christine has figured out ahead of time. What the heck are we solving for?
nothing, you see if it equals.
We're going to solve, you can literally solve for anything and see if it's true. But the easiest, the most intuitive, it would be to solve for the displacement and see if it's 30 or less, right? Like if the braking distance is 20,
It's good.
then she can stop in time. If the braking distance is 35, then guess what? She's going to be stopped in the middle of the intersection and we're going to come up.
I don't think you should always.
Okay, so you got to kind of turn the thinking around a little bit here.
You should be
Right?
slowing
You
down.
know the allowable distance. It could
You
be.
gotta figure out what a scale green.
Come on, Talia. What's that? It's like you don't know her actual braking distance. You only know how much room she has to brake. You know, because you want to see if the actual braking distance is more than or less than 30. Okay? 50 divided by 3.6 gives it to me in meters per second. Right? Okay, so I'm going to take 50 divided by 3.6, and I'm going to, that's 13.9 by the way, and then I'm going to square it. I get 192.9, right?
Yes.
So 0 equals 192.9. 2 times minus 6 is minus 12d. And so the d value is that 192 negative divided by negative 12, and you get a displacement of 16 meters.
She has lots.
She has lots of room,
Yeah.
right? That's what it meant.
Yeah.
She can brake from 50 to 0 at a deceleration of minus 6
And she would make it into.
in 60 meters. She's got 14 meters of room to stop. She's got lots of room. Just hit on the rate.
She can go even faster.
She can easily stop in time. Okay? She can stop in
Wait, so
the
that
space.
she can't make it faster.
Well, we don't know that yet. We don't know.
I'm gonna guess.
She can stop in the space allowed. Okay, so that's the stopping one. Okay, now what about going? Can she accelerate? Can she accelerate and go? Now, how far does she have to go? Not 30 meters. No, 42. 12 more. She's got to go farther.
All in 2 seconds.
All in 2 seconds.
Can't be.
It feels like it's not going to happen, right? Feels like it's not going to happen. Okay, so how are we going to do this? We have to know the distance traveled if she accelerates, right?
Yeah.
We have to know the distance traveled if she accelerates in that time, and then we're going to check to see if it's more than or less than 42, I think, right? We're going to do the same kind of deal.
Okay, this is easy.
Do we? Yeah, it's not that hard. Do we have the acceleration? We don't. So we need her we have her deceleration, but we don't have her increase. So VF equals VI plus AT.
What about that? I mean, I don't know how it would work, but it says that it takes 7 seconds to go from 50 to 70.
That's how we're going to find her acceleration. Right? So what is the final velocity?
Right.
70.
But that's 70 kilometers an hour, so it's really 70 divided by 3.6, right? 13.4?
90.
19.4. Oh, jeez. Oh, that's squared. And the VI was 50 divided by 3.6, also squared.
Yeah, why square?
I don't know.
Understanding what's happening.
Thanks. I was thinking the other one, yeah. 13.4, I think, right?
No.
13.9. 50 divided by 3.6. You got to convert kilometers per hour to meters per second. I don't have the acceleration. I only know the deceleration. Slowing down at minus 6, but I don't know the speeding up. This is the speeding up one.
Do we have the time?
We do it 7 seconds, I think, right?
Oh, yeah.
So A times 7. So the acceleration is going to be 19.4 minus 13.9 all over 7. Her acceleration is a puny 0.79. Not feeling very good, is it? So we want to know how far is it going to, no, in 7 seconds, how far does she go? That's what we want to know, right? 2 seconds, that's what I meant. VIT plus a half AT squared. Initial is that 50 divided by 3.6, which was 13.9. She's only got 2 seconds. 2 times 13.9 is like 28 meters. 1/2 the acceleration of 0.79. And the t squared is, I got to move this just a smidge over. Yeah. Yeah. 0.79, and that's going to be squared. Okay. Oh, no. Time. Time is 2 seconds. AT squared, yes. So 13.9 times 2 plus 0.5 times 0.79 times 2 squared, which is 4. And I get? Yep. 29.38 meters.
I did not get that. That was
But she won't even make it past her.
She is not even going to make it to the start of the intersection if she guns it. I guess. Important stuff. Break.
Break at it.
Yeah.
If you're 30 meters away and you have to
She's only going to get to their pass yet by accelerating, right? So this is the case. That's showing how 2 seconds to make that.
That was so bad.
Another red light.
I don't know my mom did.
All right. So, let's have a look at the textbook because I know there's Fred and Marnie style questions in there. So that's fine. How do we get that? For a long while. No, no kidding. Zeros. That accelerated a lot more than this woman, that's for sure.
Yeah, that was a 7.
You would have made it through the wall.
Yeah.
Yeah. Rocket Man over here. I have very little here.
Would you say like 2 ones?
I would do them from that page until you're feeling comfortable.
Wait, we're doing questions.
Okay, so the Fred and Barney style questions that are in the book are question number 12, page 75, not number 12, sorry. Page 75, number 66. Page 75,
Hey.
number 66. 2 rugby players are running towards each other. Fred and Marnie. Kaboom in the middle. Okay?
Yeah.
Number 68 on the same page is a Fred and Barney style question. That's number 13. Oh, why am I? It's like number 13. Okay? So those are 2 there. And I have this one here that is a Fred. I made this one up. Okay, and then there's the pretest one. So I'll help with these, but the pretest one is on your own.
Are these solvable?
I will mark it, but it does not count toward the final one.
Because everything are solvable.
I don't know. What are you talking about?
So,
I think like the bigger has to one that doesn't have an answer to it.
like, will I go down next month?
Oh, like when you can't catch the bug. No, like like when it's actually like it's not possible. No, there are some that are possible. I can't read it. Yeah, math.
Yeah, sometimes they don't do it on purpose. Usually some editor makes a change and then they forget to tell the person that does the answers. That's how Okay, so I'm going to be quiet for a while. In a few minutes, I'll hand out the free test. Use your time wisely. I'm going to start vectors on Monday. Vectors. Committing crime with both magnitude and direction.